They don't need much of an introduction to Nico Jasudis because they learned about the C++ standard library through Nico's book of the same name, and which I went on Amazon, and there they classify him as a best-selling author, and that also enlightened me to, Nico has written other books too. They may perhaps have not been the sort of blockbusters, but that's one of the ways he makes his living, is writing books about C++. He has been a member of the C++ committee for many, many years, since the late 1990s, and the authors are important members. There aren't very many of them, but they're important members and contributors to C++, because they're the ones that try to have to figure out how to explain this stuff. And so they're often the early warning of, we've got a problem with the standard library or the language. And I think some of that you're going to probably hear about at this talk. The other thing I want to point out is that Nico has ties to Boost. When Boost was 6 or 7 people still at that level talking about it, Nico was one of those people. And as to sort of get ready for this talk, he unearthed a fragment of an email exchange between he and I
have it on a slide later.
It's dated July 1998, where we're trying to decide whether, because Boost had just been going, I think, since May, and we're trying to decide if he dares put the URL or references to Boost in his book, which is just about to ship pretty soon. And we're trying to decide, is there any likelihood Boost is going to last long enough to, for his book to get out there on the shore still. And we decided, I think in the end we decided it was, there was running that risk. But
it was your decision, not mine.
The reason Boost thrived is it caught fire with people, users primarily. So the early people it caught fire with were incredibly important, because they're the ones that let those of us that were active in this know that the community cared about Boost and that Boost was important to the community, and that motivation was incredibly important in the early years. So anyway, here's Nico Jasudis. Let's give him a big hand.
Thanks. Thanks a lot, Beeman. You have stolen the first slide, half of it. But maybe I replace it by another story. My first meeting with C++ standardization was in 1997 in London. When I entered the lobby, I didn't know anybody. But I saw there's a crowd of people, and they were chatting around. And suddenly there came somebody out of the elevator. It was Beeman afterwards. And a little bit later, there came a nice woman out of this elevator. And she came there, looked at the group, went to Beeman, gave him a big, big kiss, and said to him, "Now you have to tell me your name." It was Beeman's wife, I found out. So this was my beginning of the first standardization meeting, and it was really exciting for me. I'm not a native English-speaking guy, as you probably have heard already. So a lot of things were new and exciting. And to tell you some truth, I was about to think about writing a book about the standard library, but there was already a book out, which I wrote in German. So before I wrote the English book, I wrote this book in Germany discussing the C++ standard library before the first standards was published. And as I said, I came to this meeting and I said, now people have to understand that I'm helpful. So they had, as I told the day before yesterday in the evening session, we didn't have laptops. We worked with papers. So there was one task asking, well, here we have a bunch of paper and we missed the page numbers. So I said, yeah, I can add page numbers. I thought this is not a critical issue for a German guy. It turned out I was wrong. Because what we learn in school is not that you spell English digits different than in German. So guess this was a paper, this was not the original. I added my understanding of what is a 1 or an 11. You might see that, well, most Americans might think, oh, this is a 7 or 77. And it turned out that during the meeting, when it happened once that somebody said, oh, please look at page 11. And they said, oh, this is crapped. These page numbers are crapped. So that was my first lesson. So that's, for example, 17 in Germany. And by the way, that might be the moment, if you just see this on the desk, where Bjarne Stursup came around and saw my book with some bunch of paper above it, and he only read Die C++. I had a hard time at the first meeting, I can promise you. So that was the beginning, and as Beeman already said, or as I always said, English is not my native language. Another thing I have to say is I'm not a C++ expert or core expert. You are probably a lot better than me. I can be very slow, but I'm pedantic. That's good for writing books. I really have to understand things, and then I can present them. And the consequence is here, you will not learn anything from this talk, because I want to learn something from you in this talk. So I will raise a couple of questions instead of answering them. Okay, so Beeman already told the story of this slide. By the way, that was the first two places where I mentioned Boost inside this book. One was about shared pointers, and the other was about compose function objects. These are the only places where I asked him for permission to discuss it. Okay, so you all know the role of Boost we have now, and however, maybe it's not clear how essentially good it is, and I think how it contributes to the success of C++ 11, 14, and 17. This is a current picture without the Boost here, how we work in the standardization groups. And as you can see, we have 13 working groups which discuss new features and new libraries. And then we have the evolution, the new stuff for core and the new stuff for the library. Then we have the guys that just do maintenance for the existing stuff in core and for the existing stuff in the library. And then we have the full committee. And whenever we decide on something, ideally, if it's a library, ideally we have an implementation in Boost. Then this went to a working group, say the file system working group. So we start to standardize it. Then we, in the general panel of the library evolution group, and in library we look at it, we approve it, and finally we vote on it. And this is working very, very well for new libraries. The reason is that most of these libraries exist already in Boost. So that process works very well. However, we also have new language features in C++. And there we take the other path. And there we have a problem, because it's not easy to implement a new language feature, to get some experience and to understand whether we design it well or not. So there might be some implementations in compilers, and usually we ask for it. So is there some implementation experience for no except in some library? And but that comes very late. And the really bad thing is when core people decide on something new, this usually has an impact on the library. And that means we have to adapt. That's a problem. So somehow we need to exchange things, and as you probably would expect, we have last-minute changes, and these last-minute changes might impact libraries, existing libraries, and that can cause a lot of trouble. So the day before yesterday, in the evening session when you grilled the committee, the question was, are we happy with the process? I'm not sure. We have a problem here. And I give you some examples where this occurred. So this is a timeline for C++. Let's look what happened with C++ 11. So the goal was to have it out as C++ 11. So we, the meeting schedule was scheduled in a way that we would have to have the final content ready in March 2011. In 2009, we had a problem. We found a problem. The problem, you probably all know, is that we found out that the new concept of move semantics breaks the strong guarantees of vector pushback. That was raised 2 years before the final vote. I mean, you might say 2 years is a long period. We meet twice or 3 times a year. And most of us do the work for changes not as a major job, just when they have time to do so, maybe as part of their job or maybe as part of their free time. So that means we have found a significant problem, and we have 3 or 4 more meetings time to fix this problem. So first we had to discuss this problem in detail and to find out how should we deal with it in general, especially in the language. So as a result, 1 year later, we voted on adding the new keyword no except as a consequence of dealing better with move semantics and exception guarantees. That means we have 1 year left to deal with no except in the library, in the existing library. And by the way, this was just the approval to have the new keyword. The next meeting in August, there was still on the agenda final clarifications on no except. That means we more or less have at most 2 meetings left to understand what this means for the library and then make the appropriate changes. My battery is low. So we had a problem. We started in a big chaos to add no except here and there, and that could be fine. We had a couple of proposals. We did the best we could. And we came to a moment where we said, that doesn't work that way. We need at least to have some idea, some guidelines, how to deal with no except in the library. So how to apply this new language feature. There's one of those guys who made the go and rescued C++ 11, John. Thank you very much. Because John and Alistair, they worked on it and they started to provide a policy or guideline how to apply no except. They first wrote a paper, we need that policy, and then they wrote a paper, this is the policy. And the policy was raised in the March meeting in 2011. That's a meeting where we vote on the standard, just to find that out. Yes? So in that meeting, we had the guideline, and then we apply the guideline, and then we vote on the standard, and that's it. That's a cool new C++ 11 standard. So I think for that, it's not too bad what we have in C++ 11. It could be a lot worse. So here are the guidelines, more or less literally taken. Each library function having a write contract, which does not specify undefined behavior due to a precondition. And when the library working group agrees that it cannot throw, should be marked as unconditionally no except. If a swap and move or move assignment operator can be proven not to throw by applying the no except operator, then it should be marked as conditionally no except. No other function should use a conditional no except specification. And this was because we knew that it's very, very important for the strong exception guarantees and for the performance of pushback to do the best we can to say when move operations do not throw. We can skip the other stuff. Yesterday I promised to answer the question, why don't we have a guideline saying no move operation should throw? So why don't we specify, can it be that we have any useful beast in the standard where it's okay to throw an exception under some circumstances in move? And the answer is, as always, allocators. If we implement move for a vector or for a string, and we change the allocators, this is not possible. So we have to throw in that situation. Sean gave yesterday a talk that the whole approach for allocators might be broken, and this is maybe one consequence of it. So, that was the design policy, and we followed this policy mostly. A very typical example is basic string. Basic string, move constructor, and move assignment now are marked as no except. Great. Well, you might have seen that we have a library issue. The library issue 2319 is a proposal for C++ 17 to remove this no except requirements for the move constructor. We voted on that in Seattle, I think. It was pretty close whether we adopt that or not, and whether we adopt that for C++ 14 or not. The reason to be able to remove no except was that one compiler wanted to be standard conforming, although they might throw in move operations just as a debug feature. So only in debug mode, not in release mode. But in debug mode, they wanted still to be standard conforming, and it's not allowed to be standard conforming by skipping the no except there. We had a vote on that, and the decision was, okay, let's go into this direction. I was strongly opposed that. I have that's for the records. And it's now, this issue is ready for C++ 17. And I said, well, let's move it to 17, because what I really don't want to have is that here we have no except. That here, there's nothing. It's okay to have something saying here should be a no except, and under some circumstances, this no except can be skipped. And I started to make a proposal, or to do a request on the library reflector to make a proposal how we mark something as this should be no except, but it does not have to be no except. So that raised a long discussion, and as a result, a couple of things happened. First of all, it turned out that vector move operations have no accept specification. We don't have them in the standard. That means that if a vector contains vectors, we have a problem, or we have bad performance. Howard Hinard wrote a little test program. Look at this test program. We have an object, and here we have, with a macro expansion, a no accept, so we can turn it off or turn it into a lowercase no accept. And here on the right side, you see, let's create a vector of, what is this, 1 million elements of this piece, of this class with strings inside. And let's then add one element. And measure the time. It's not exactly that, I slightly modified it, but the essence is exactly this program. So that was the result. It turned out with Clang, C++, with O3 optimization, the no accept version was 10 times faster than without the no accept. It's not 10%, it's 10 times faster. Or to give you some more numbers, without no accept, on the Clang compiler, we had something like 230 milliseconds, and with no accept, we had 20 milliseconds. I ran the same test again today, this morning, with G++49 on a different machine. It's not a proof that G++ is 10 times faster than Clang. So I had these measurements. I couldn't get any useful number for the no accept version. But when I raised to 10 million objects, I again got something like this factor of 10. And then I tried 100 million objects, and I got a core dump. Okay. And it's, by the way, I put a try-catch bug here. It was not a standard exception. There's something broken inside then. Okay. So these are huge, huge numbers. And that changed a lot in the discussion of the library team. And now we agree all, I think, that we will change this recommendation to remove no accept from string move operations, and we will add no accept to vector move operations for C++ 17. Which, however, raises the question, how do we deal with the other containers? So how do we deal with stack, list, associative containers, unordered containers? We don't agree on that now, according to the discussions we have. So it might be that we still want to have something like, can we specify in the standard something like, this should be no accept, but you're not required to. And then still we have the issue, how do we formulate that in the standard? It's a formulation question for the standard, not for source code. So I asked for some proposals. How could we do that? We can maybe write the no accept specification in italics, which is bad because then it's a font issue. We can just uncomment it in the standard, or make no accept attribute. Some form was discussed of no accept depending on the ndebug, which also has its problem. I come to that in a moment. No accept probably. Throw unlikely. And Gabi is not here, huh? So I can tell you the last proposal came by Gabi. Heavens. Okay, was there a question? Or?
Currently, compilers have flags that turn off standard features and therefore make them non-conforming. Why can't those compilers do effectively the same thing?
Yeah.
in web mode?
The question is, we already have features that make compilers non-standard conforming. Why don't we deal with that? This was discussed in the reflector, and we have strong opinions in both directions. So one opinion was that in the compilers, a lot of people use debug mode and as a default mode, at least during development, but even sometimes in when the system runs. So in this case, it's important for them to be still standard conforming. But that's a valid argument.
So some of us raised the issue in the committee that certain compiler vendors' debug modes were already non-conforming. So what the heck was the issue here?
Yeah. Exactly. I don't repeat it for the record. It's okay. So because I have not enough time. So it's not over yet. So one thing in the discussions about that, one thing that was proposed was, should we add the no-except guidelines as follows? If the move constructor has a no-except specification, then the default constructor should have a no-except specification, because they are more or less twins. It's more or less they jump into the same state according to how move semantics is currently defined in the standard. Yes, this was also discussed a little bit, but for example, one counter argument was, I cannot find anywhere in the allocation requirement that if the allocator is default constructible, that it is no-throw default constructible. So again, the allocator raises some interesting questions. So we might come up with something saying, so the default constructor of vector is no except if the default constructor of the allocator type does not throw. That's something we have to discuss, and we have to discuss whether this results into a new guideline or policy. And we had other opinions here. One is, in my opinion, the whole current guideline is broken or wrong, because, for example, it sets up a conflict when I specify something like operator star. We now need to make a choice between adding a requires clause and a no except. This does not improve the quality of the specification. I don't discuss it yet now with you. Just to make you clear, we are under discussion about how to develop the no except guidelines for the next standard round. So what do we learn from that? First of all, what we learn is, oh, Gabi, it's good that you came now and not 5 minutes ago. Ask me afterwards why I said that now. It's key to have guidelines for how to use C++ core features. Ideally, we need them together with the new features and not later. But guidelines require experience and are living documents. So that's a problem. So let's look in some other areas where I think guidelines could help. Initializer list and explicit. Initializer list, a new feature in C++ 11. So my question is, what does this program print? Think 20 seconds about it. No, what does it print, not what does it print. Where are the statements in error or where are they valid? Okay, the first two guys is clear. This is not the default constructor, this is a function declaration. Without any arguments or call, we require an argument. Here we have the 47. It's an integer, no explicit for the constructor taking an integer, so this is valid, fine. So how about the others? We pass an initializer with 0, 1, 2, and 3 arguments. That's it. The initializer list is explicit, so there is no implicit conversion from an initializer list to P, what is required in foo. However, the overloading rules say if I have multiple matching constructors, the first thing I try out is a default constructor, then I try out the initializer list constructors, and then I try out all the other constructors. So therefore, without any argument, it's okay. And that, by the way, has also an effect on declarations. If you declare objects using initializer list syntax or the new uniform initialization syntax, it's important. The explicit plays a role if we use copy initialization. So if we put an assignment operator here or assignment character here. Yes, this is okay. This will fail to compile. Which is a little bit, well, I would say at least unfortunate. Yes. Let's do it the other way around. Let's put the explicit in the ordinary constructor and remove the explicit from initializer list. And we have the same arguments here. So now if I declare something without the equal sign, it always works because the explicit doesn't play a role. But for copy initialization, it plays a role. So it's an error to assign the empty initializer list. It's not an error to assign multiple arguments in the initialization list. That's also unfortunate, probably. And it's even more unfortunate than you thought because we have that bad design in the standard. We have here class vector, we have the default constructor being explicit defined and the initializer list constructor not being explicit. And that has the interesting effect which Marshall and Jonathan told me. If you write a template, a variadic template, and you pass the arguments for initializing the vector with the equal sign, it will compile for 1, 2, 3 arguments, but it will not compile for 0 arguments. Is there something?
Yeah, so 2 slides back where you had the error with the explicit initializer list clause. Would that error go away if you had 2 sets of braces instead of 1?
If I have 2 sets of braces, would that error go away? I don't think so. But the answer is no. Thank you. Yeah, I know that yeah, enough. Good. By the way, I'm thinking about proposing that explicit doesn't play a role in copy initialization, so that this is always valid. Not only in copy initialization, not in function call. Who would like to have that proposed? Who would not like to have that proposed? I skipped that. Okay. Other thing to do. Okay. Yeah, so we have library issue 2193, where we fixed that for C++ 14. Last minute change, was it?
The old one had to be explicit because otherwise you could implicitly convert an allocator to a vector. that with that.
Yeah, exactly. So the reason it was explicit was because of the allocator, and we don't want it to have an implicit conversion of an allocator to a vector, which could be a nice feature to confuse people. So we split up these functions in two. And by the way, this is a problem we fixed in all containers. But we have more. I mean, it's an interesting question. Look here, the vector taking two input iterators is not explicit. So there's an implicit conversion from two iterators to a vector. Is that a good thing or not? I'm not sure about that. Marshall?
I'm not 100% convinced that it's a great thing, but it's far less dangerous than the single argument implicit convergence.
So you think your argument is it's always more danger if we have a single argument conversion, because there we don't need the curly braces for initialization. Yeah. Good. Okay. So this is something we might also discuss. Do we need guidelines for how to deal with explicit? Well, I think we need guidelines for that. And a different question is, what should be written in these guidelines? I'm pretty sure that one guideline should be the default constructor should never be explicit, and the initializer list constructor should never be explicit. And any other constructor should be explicit if the values don't fill directly the value of the object. So the passed arguments don't fill directly the value of the object. So if the parameters affect behavior instead of core content, then there's something we have to discuss. And then we can discuss, should this rule apply only to one argument or to multiple argument places? Yeah. And by the way, as a side discussion, we might think about, shouldn't we always declare the default constructor separated from all other constructors? That's also something we have to discuss. That might raise the number of constructors. Tuple has already 18 constructors. So there might be some bad consequences. And by the way, it's an interesting question. Which of these constructors should be explicit? And some nice counter examples of strange behavior caused because some are explicit and some are not. That's for C++ puzzle books. Okay. Next example. Do we need guidelines for constexpr? No?
Well, we have them.
We have them?
We have at least one.
One guideline is don't use them, or what? No. So what is the guideline we have, Marshall?
The guideline that we have is that that standard library implementations are required to put constexpr exactly where it is in the standard and nowhere else.
That's not well, he said we have a guideline saying that implementers should put constexpr only where the standard requires that. If and only if the standard mentions that. That's, by the way, a different rule than for no except.
Absolutely.
So we have different rules whether there's freedom for compiler vendors to add no except and to add constexpr. So that's not a guideline. That's I would say that's the question: is it standard conforming or not? So the guideline we need is: so where do we put the constexpr in the standard library? And there was recently a thread about that, a discussion in the library working group or in the library reflector. Let's look at something that was discussed there. Some proposal was constexpr is not for optimization. So a proposal for a guideline was constexpr is not for optimization. The compiler may can inline well already. Use constant when guaranteed static initializations is important. For example, the construction of global atomics really cannot be deferred to runtime. Use const expr when you anticipate using the results to define array sizes or appear within template non-type arguments. But that was the first proposal how to deal with const expr. And then additional arguments flew around. I think that making everything possible is borderline insane. It leads to unnecessary increased compile times, potential code bloat, and wishes to overload on const expr so that we can select different algorithms for compile time and runtime. Okay. By all means, be generous, but use const expr only when there is a potential need for guaranteed compile time evaluation. The response for that was, beneficial uses of const expr on non-trivial computations aren't always obvious from past experience. That says experience might not even help. There seems to be a potential need for everything that can be const expr to be const expr, and that's exactly an impression I have. How do we gain confidence that nobody's going to need to use some function in a static initializer? So this is raising the question, shouldn't we place const expr whenever we can and whenever it is allowed? I saw someone asking if main could be const expr. In the email here, there was I don't know whether he was serious about that. That did scare me a lot. It will not be easy to draw a simple and clear line between const expr and non-const expr in the library, but I think we have to try. Yeah, okay. We are supposed to be experts. Okay. So we should be better at drawing a line than the average programmer. Const expr can always be added later when there's empirical evidence showing benefit. The problem is when us experts get it wrong, everyone else waits years for us to release a fix, because we ship new releases every, I don't know, 3 years now. As per our vote, vendors are not allowed to offer a fixed version as a conforming extension. Yes, I don't think this is a question we can ignore, but for a solution to become a rule, someone has to propose something and gather a consensus. I'm looking for volunteers here. Anybody here? Okay, because the problem is, if we don't do that, the mess will continue. And I think if you read all these sentences, it's a clear sign we have a clear mess here with const expr. Maybe we have to wait until Scott Myers or Herb Sutter write a book about it. Another example. I start with a question. Which library function has changed with each and every C++ standard? So we have different versions in C++, 19.8, 03, 11, and 14.
The constructors for standard vector?
The constructors for, but that's multiple functions. Just one function. Pushback? No, probably not. Oh, the answer is make pair. So we started in 98 with this approach. Make pair, taking the arguments as we all learned as constant references to avoid unnecessary copies. We knew that. That is how it has to be. Well, there was a problem, though. Because make pair, if you did pass the string literal, or an ordinary C array, the same problem, the resulting pair was a pair of int and an array of 3 characters, according to language rules. So, that caused interesting problems. For example, you couldn't compare the first element of a map with 42 and high and another string. I tried that out. I just changed the current G++49 version and hacked make pair to add const reference again. And I got an error message with 238 rows for this line. Clang is probably a lot better, I know. Yeah, that was nasty. So we discussed that. Well, Andrew Koenig filed a defect in 1999. And yeah, we claim that we have a problem. And another problem is that this const character array is uncopyable. Okay, so we discussed that. Here is a proposed resolution from our defect issue list. So the proposed resolution was to change it to pass the elements by value. And here is the rationale for that. 2 potential fixes were suggested by Matt Austin and Dietmar Kühl. One is overlaying with array arguments. The other is use of a reference traits class with a specialization for arrays. I'm pretty surprised that we didn't do one of the things. Andrew Koenig suggested to changing to pass by value. It appeared that this was a much smaller change to the standard than the other 2 suggestions, and any efficiency concerns were more than offset by the advantages of the solution. One of the few decisions we made in the standardization to make things slower but more convenient. Gabi.
We make change based on the size of the diff, is that what you're saying?
Pardon?
The changes based on the size of the diff.
Are the changes based on the size of the diff? I don't understand the question.
The size of the change to the standard, I think.
So you mean so to keep this change small, you mean? Yeah, probably. I'm sure that this was an argument because we wanted to change this for 03 and we want to be as stable as possible. That was definitely an argument those times. So with 03, we changed make pair to be by value because, just to make sure why is this change effective, because by rule, template arguments passed by value decay. That means they convert the arrays into pointers. For references, by rule, template arguments do not decay. Okay, so we solved the problem. Fine. Okay. Then we got C++ 11. Well, we want to support move semantics. For move semantic support, we need references. Reference parameters, template parameters don't decay. So we have the decay problem again. So we have now to make a real fix of the decay problem. And that's the result. That's a very, very simple function. Are you able to maintain make pair anymore? Well, you are probably. Even Marshall is able to. Yeah, so we have type trait, std_decay. Well, colon type name, of course, because type is a type. Yeah, so it's obvious and clear and everything works fine. I should mention just for completeness that we do more than before, because the standard decay trait also strips const validate qualifiers, which the inbuilt library language rules do not. Okay, so this was the version in C++11. And then we made the final nice fix in C++14, strictly speaking, not changing the semantics. Instead of writing type name std_decay t1 type, we just have to write dkt, because dkt is a new shortcut for decay type.
Why not go back to pass by value, but just move the arguments in place?
Why not go back to move by value? Well, because we need here this forward. I think there's no way for this forward to do it. Yeah?
Those are sync arguments.
Yes.
Yes. So we pass them by value, move them into place.
Okay.
Let's change it.
So let's change it in C++70. Yeah. I mean, that exactly raises my point, which was raised already yesterday by Tony, by Eric, excuse me, do we have guidelines, or shouldn't we need guidelines, how to declare template parameters now? Or parameters in general, but also template parameters. That was the question.
Let's go back, why not to pass by value? Because we don't know whether T1 and T2 have constructors. That's one thing.
You say one problem with by value is we don't know whether they have more constructors, more move constructors. Okay. Gabi?
It looks like it is not that we don't know how to make guidelines. We just don't know how to make pairs.
So the comment was, it looks like that we don't know how to make, what was the first thing?
It's not that.
We only don't know how to make pairs. That's what you say. Okay.
I don't think that changing it to take by value would work, because we don't actually know that T1 and T2 are value types. They could be references already.
So the argument is the past arguments could already be references.
So if you force move them, you've stolen them without value.
But you still have a copy of it.
No, still have the decay.
They were saying that they were going to move T1 and T2.
But make pair relies on argument action. People never take reference arguments and change it. If you want a reference, then you need still type, not specific pair.
So for the records, interesting discussion in the audience. I'm close to understand the details here. I mean, I got some arguments by Eric yesterday. I'm not the expert here. But what I say is, I want to have a guideline. That's my point. By the way, there's an interesting trick, because you always have to write twice now the return type, one here and one in the return statement. So a nice trick used by GCC is that one. Introduce a third template argument with the default initialize it by this return value, and then use this third argument twice.
But if that's the C++14 version, make it auto.
If that's the C++.
The C++14 version, make it auto, remove the return type.
Okay, make it auto. Yeah, that's something we can do now. Yeah, so there are a couple of reasons now to change make pair for C++17. Okay. But actually, this is not done in GCC because Jonathan, I asked Jonathan about it, and he only used this red trick internally because he said, if I do that, some clever programmers will find out that there's a third argument and will explicitly pass arguments to this third argument. Yeah. Sneaky little buggers are the programmers. Yeah. By the way, just a side note for those who are still using VI or Vim, to be able to program that, there's an auto command to find out the matching closing angel bracket for templates. So, yes, the problem is we need guidelines for how to pass template parameters, or in general for how to pass parameters. Maybe something like, if you know that this slide I prepared before I heard Eric's talk. Maybe or after discussing it in Seattle in a beer round, I should say. If you know that the object is always cheap to copy, then pass by value. If it might not be cheap to copy, you have to make a choice. If the expected type is likely to be an R value and is movable, then you call by value so that the caller passes temporaries or uses move. If it's not cheap to copy and not movable, then still take by value and let the caller use stdref. Otherwise, use const L value references and think about whether and where to decay. If you return something in the argument, use a non-const L value reference. And if you have to pass move semantics into other parts of the called function, declare a universal reference and forward, and think about whether and where to decay. This is probably not correct. I know that from what I heard here yesterday, for example. But this is a starting point for discussion. Eric, yesterday, thanks for allowing me to show this slide. He had other recommendations now, similar but slightly different. And the most interesting different recommendation was if there's something, an input-output argument independent from whether it's a template or not, use a stateful algorithm object. I don't explain details now, if you haven't been in the talk. So the whole point I have, if I need guidelines. The bad news is I might have the task to provide these guidelines. Well, not me, but my co-author, because as you probably know, I'm also one of the authors for C++ templates, and we are about to preparing a new edition, and probably in a new edition we have to answer this question. So we have to discuss it. But that might come too late for useful changes in the standard library.
Can I just make a general observation? I think the fact that 3 years after the standard has been passed, we still don't know exactly how to do something as fundamental as passing values to functions. I think that's great.
Okay, I understand that as a sarcastic comment, that after 3 years of having this standard out, we still don't know how to deal with it, that this is great.
That's a fundamental thing.
We have a fundamental thing. Passing arguments into a function, we don't know how to use it or apply it. How to do it.
I think that maybe the real issue here is that we look at other languages and it looks simpler, but that's just because they settled on a less performant solution. And so these changes that it's going through are ways to improve performance that you can't get from other languages without even more complicated tricks.
So the argument is that this might be a special problem in C++ because we have features that allow more, especially regarding performance. So other languages don't have this problem. Yeah, I mean, both is probably true. So we have to work on that. That's the point. I don't see that anybody's working on that, by the way. That's a problem. So no, I'm not aware of anybody working on these guidelines. Tell me if I'm wrong.
Is Scott Myers not generating his next creation, which I would expect would address it?
Yeah, so maybe Scott Myers in his next book, as you said, is addressing this. Maybe Herb in a blog, I don't know. Eric in a talk. Yeah, but then we still then need consensus. And then if we have the consensus, then we can make pair again. Yeah.
That comment is probably true, but your issue is that you want these guidelines for the library itself.
Yes, I want...
Earlier than the books for programmers.
Yes, my point is I want these guidelines when the core feature is voted on. So when we vote on move semantics and universal references and auto and decal type of auto, I want to have these guidelines. Which of course is only raises a couple of problems. One is these features might not be implemented yet in a compiler to make some experience and some measurements. That's our big problem. That's a big problem. We can change the standard in the library at the last minute based on some things we found in Boost and some experiences we made in Boost. And we have a lot of time to understand whether library features work or not if they use the existing core library features. But when we introduce a new core library features, we have a problem. And I don't know how to deal with that. I mean, we can say any new core language feature is only valid one standard later. So C++ 17 is only for library features. What we discuss now as core features will become, after we have voted it this year, it will be valid in C++ 20. I don't think that's a good solution, but it's something to think about.
Why not split the library process from the language process?
Why not split the library process from the language process? But we have it split already. I mean, that's a problem. It's not a new problem. I have worked in projects where we said, so some people work on the framework and some people work on the application of the framework. And you usually build your release for the framework guys earlier than the other. So, but
I mean more split the ISO approval process.
The ISO approval process. So the suggestion is maybe we change, maybe we make the ISO approval process to say we have core fixes and then we have library fixes and they are independent from each other. I'm not sure that this is a good thing because there is some relations between core language features and the library. Okay, I don't have a solution. I just want to make people aware of the problem we have. Something will happen. Sometimes you learn it the hard way. So, my message here for this group is it's key to have guidelines for how to use C++ core features or significant C++ core features. Ideally, before we have to adopt them in the library, which is way before Scott or Herb write books or blogs about that. Michael.
So, I think the problem goes further than just lack of attention at the design level. Sometimes these guidelines cannot emerge until you have seen the whole thing. Many of the problems we've observed is an interaction, say, with move semantics with no exempt. When we put that in context, we add that with another one, with auto, with templatized default arguments. Now, some of those might not even have been invented.
Yeah, you say it's hard to, because some of these features interact with each other. And I would think, but by the way, this is nothing new. We had that in C++ 19.8 already. if we would have known the consequences of namespace, we wouldn't have that feature in that way in C++ 98.
So
or at least ADL, yes?
Just to follow on, one possible suggestion is, it's great to wait for the book, but maybe one possible suggestion is that the standard has this TR process still, different than the TS process, which maybe you'll explain. And I can invite you if you want to know. And maybe we need maybe the standard should spend some time gathering people together to build a TR on the guidelines after the emergence of a new standard, and given sufficient time and experience.
So you said that maybe we use a TR, which is a technical report, and as an extension to TS, technical specification, to make a two-step approach here. Yeah, I don't care about the details here, and I just want to, maybe I should say something. This problem, to some extent, is natural. So the least thing I want to make sure is that you know about this problem, and the other thing is that we care a lot more for having early guidelines, so that we are interested in guidelines, especially when we add new core features. It seems that we have a lack of a view in the standardization group how to use features. We are keen on new features, but we have a lack of reflecting on what is the effect, what could be the effect, what is the outcome. So it's okay for me to have some initial guidelines for a new feature and then find out later, as we have learned with the no accept policy. And but we should have something like that. So in a company, I would say there has to be a quality gate for that before we adopt a new feature, that we have some initial guidelines.
As far as I can say, big picture is the LWG people and EWG people without communicating.
So you say the problem is that LWG and EWG guys don't talk with each other, whether it's the evolution working group and the library evolution working group. Well, yes and no. They talk to each other. And by the way, it's not exactly that. It's I have to go back to one slide. Hello, there. Well, in general, we talk. And in general, people go around in the meetings and go into different rooms and all. What I am discussing here is that we have in core a new feature, an evolution. This has to be discussed not with the evolution library group, but with the core, with the library maintenance group. And guess what? The library maintenance group is the least coolest group in this standardization group. We have sometimes problems to find enough people to get a quorum, which means we need something like 6 people. So, and we know all each other. So Marshall is there, Stefan, Jonathan Sobop from the compiler vendors, one guy. I am there, and Alistair Meredith and 2 or 3 others. That's it. Because the cool and fun stuff is done in the other groups. New features, great. But how to apply these features, that's part of this group. And this group has a tremendous problem now, because again and again there are new proposals and we all have to review them, and we only review it. So does this fit into the general schema of how the library is designed? We have no time to discuss any guidelines that follow from that. Other than what I said, what happens is that we find out that we are going into a mess. We avoided that mess with no accept. We have a little bit of a mess with explicit, which we will clean up now. And we have a complete mess with const exp.
I'm fascinated by our process. In a company, we spec, design, implement, we test, we document, and then we release. It's a standard, specify, document, release. So then we start implementing and testing, right?
No, that's not the question. Is there one problem that we do testing after we release in the standardization? That's not strictly true. I mean, we release, but we release locally for this feature, so we don't have the common view about everything. So is this library feature implemented? That's a common question. Yes, it is. And there are also some core experiences. So you have something in mind with const exp. Yeah, I can check that min and max now with const exp have that and that effect. But as Michael pointed out, we don't have something like an overall test suite in an abstraction layer of how deal with features with each other. We have a lot of test suites, is broken or not. But what does this core feature mean in general for how to use C++ in libraries and for the application programmer? That's a problem, yeah.
We release the standard and then the compiler is implementing. So maybe it would be better to make this will be what we want to do, then we get to implement it in the compiler. Then the experts of the library teams test it and try and see if it works. And then we got solution standard after. So we have to be one standard after, but at least it's tested.
So your proposing shouldn't be when we develop a new core feature, then implement it, then find the effects, and after that we standardize it and we put it into an official standard. I mean, no doubt that's a better approach. The question is whether it's practical. Marshall.
Yeah, is this on? Yeah. I just wanted to remind everybody that the output, the result of the standards committee is a specification. It's not a compiler, it's not a standard library implementation, it's a specification. And then people go off and they implement this specification. And so there's a fundamental disconnect there with the idea of testing stuff. A lot of the library implementers and the compiler implementers will be out in front of the current state of the official spec, testing proposals, implementing proposals and gaining implementation experience. But they all have other things to do as well.
I think we could pronounce that I implementers to implement some feature in production first. Because if later standard want to change something in the things already being implemented and is already used in production, it's a big action from the vendors to the standard, which is very bad.
So if I understand you correctly, what you strongly recommend is to implement first, because one additional problem is once you have implemented it and standardized it, it's a lot more difficult to change it. No.
The other side, I strongly disagree we should implement and release it in compilers. Because if we do that and the feature is changed later in the standard, and since the old version of the feature is already it's going to be a big pressure from the compiler side onto the standard.
So you say the good thing with not implementing it is that it does not happen that you implement it, then make experience, and then have to change the implementation, which breaks something. This is interesting. We have the same problem, by the way, with library features. So from time to time, the question comes up, for example, it was close to the end of C++ 11. I found out some design flaws with mplace, I think. And it was a clear bad design. And the point was some implementers had already shipped this emplace function as part of their product. So the reason that it was not fixed for C++11 was simply because the implementation of this library feature was already spread out to the world. So, yeah, so I see your point, yeah.
Just going back to your guidelines, I think it's important that they not only cover using the language in the standard library, but also for everyday application development.
Yeah. So the question is, shouldn't these guidelines be only for library design, and but also for other?
Is that they shouldn't? They should also cover.
Yeah, they should also cover application programs. I cover that question exactly in the next slide. So, Chandler.
I wanted to point out that I don't know of any implementations which didn't implement and ship some C++11 features before C++11. So if you're concerned about implementers, starting off with features before they're standardized and they standardize something slightly different and implementers have to ship them, all the implementers had to do this already. It's not the end of the world. It's not scary. I don't think that there's...
That's not true.
Already implementing the standards before they are shipping. And we have been forever.
Tony?
We really have to mention TSs and the fact that we're changing the process of how we do the standardization. We're really leaning more towards TSs now, so that everything that does go into this, not everything, but a lot of things going into the standard are first a TS. We write an implementation, we put it out there for the world, and basically the world tests it for us. And then we go, oh, that was a bad design, let's change it, or that was great, let's standardize it.
So
we didn't do that as much before.
Okay. So Tony's comment is that that's exactly the one reason we have TSs, so technical specifications, so that these technical specifications implement something and provide something as a pre-standard, so that we can still change before we approve it into something like C++17 or C++20. So that's a point we raised there. Okay.
Yeah, kind of follow up on the last two comments. Like, a lot of people are talking about this as though it were theoretical. Like, it would be nice if we got experience beforehand. Like, I've been using C++ 14 in Clang 3.4 and GCC 4.9 for a few months now, and I know a lot of other people have here as well. So, like, we do have experience with this standard before it's coming.
So you say we have experience before it's out because we are in the good situation that, especially for C++ 14, almost all features were available for a broader audience and community. Yep. But still we still have some questions. I mean, all features are there to discuss. Shouldn't make pair be declared differently? Huh? So why don't we know the answer to that? I know why. Okay. To wrap up, yeah, we need guidelines. I mean, that's obvious. I don't claim about it. I know we are doing the best we can, just to make that clear. It's a process, but it's important if you have a process from time to time to have a retrospective and think about, shouldn't we change the process? And we have discussions about changing the process. But I think these are concrete needs I have now, especially for writing my books. But which means to explain it to you, as others have. Gabi.
As a community, I think we're too risk averse, thinking that if we don't take chances, then we might be imperfect. I don't believe that. Look at the C community. They're not releasing standards every 3 years. Do they have a perfect standard? I don't think so.
If I understand you correctly, you say that if we would have changed the process, so to review and try out and things, we would still not be perfect. Yes, and I totally agree. Yeah. So it's a living thing. All my point is, we have a need now for something, and I don't even know where to raise this need. I will probably, for the next meeting in Rapperswil, my plan is, it's 1 week left, to have a new version or to fix no-accept guidelines and to provide a first graph to fix explicit because I understood that topics good enough to at least suggest the obvious things that should be fixed. But for the other stuff, I'm looking for volunteers, yeah.
Just to kind of, in some historical perspective, did we have the same problem with exceptions and giving safe exceptions when the earlier version of the standard came out? It took a couple of years to realize that.
Did we have the same problems with exceptions, or did we have the same problems in the past? Yeah, I mean, there's a reason why we have no except now. It's not only because of move semantics, it's also because exception was broken. Actually, I remember the last meeting before we finalized C++ 19.8. We had a big, but we had two big discussions. One was autopoint. And the other was, could exceptions, do exception, or does the exception handling specifications we have, do they cause runtime penalties in the case when we don't throw an exception? So is there a penalty we pay? And the assumption was that we are able to implement this technique so that there is no runtime overhead in the good case, which turned out to be wrong. And same, by the way, for autopointer. Can we deal with move semantics in autopointer? There was an interesting paper, Beeman, you will remember. That was really the last decision, I think, to say that. So I think some compiler guys created some rules where, yes, this should work, this could work. And it turned out it didn't work. Yes, so we have made this mistake already. As I mentioned, namespace already. Yeah, it's not a new problem. And we still can live with it. So I'm not asking for perfectionism. Yeah, we still have a good standard. We are still making a lot of progress. I just want to move the focus a little bit on something where I think we need more focus on. So you've raised, so who are the guys who need these guidelines? And yeah, in fact, the discussion is, don't we need different guidelines? So one thing is for library implementers or for the standard library implementers. And by the way, I mentioned it the day before yesterday, we have the interesting effect that we have two kinds of libraries now. We have the foundation libraries and the libraries on top of them. Foundation libraries to bring more or less the core data type, something that you might consider as fundamental data type in a broader sense. So like vector, string, maybe thread or something like that. So and then on top we might have new implementers, maybe not in the standard yet, but this is changing, I think. But especially outside the standard for people who write libraries or frameworks and using these foundation classes. And then we have those programmers who implement classes and utilities just because it's for their business application. And then we have the ordinary application programmer. Maybe the upper two groups are the same, I don't know. So the interesting question is here, and that's correct, do we have the same guidelines or different guidelines for these different groups? And the other question is, which group has to know and understand which detail? So what I presented here as problem and features and discussions we had, do I have to present these discussions in a tutorial for ordinary C++ programmers or not? Or is it just for an advanced tutorial for those who really want to understand the details? And that's the reason why this talk is called Beware of C++. I think if I'm going to be asked which problems mentioned in this talk should know or be aware of the ordinary C++ programmer, the answer is too much. So there we still have an issue to make things better and to hide the lower layers with some abstractions on the other. But we have improvements, no doubt about that. Thank you very much.